Hi, Assalamualaikum and salam sejahtera. So as usual, please also. Okay, thank you. Hi, Assalamualaikum and salam sejahtera. So let's continue our tutorial by topic 2, which is under capacitor and dielectrics. Okay guys, so as we know, how many subtopic do we have in chapter 2? Okay, 3 of it, which is 2.1, okay, capacitance and capacitor, which is in series and parallel. Alright, and then the second one is charging and discharging capacitors. Okay, so two different processes here. We need to know what is the difference between these two processes. Alright, and then for the third one is all about the capacitors with dielectrics. So we need to know what is the dielectric material and what is its function. Okay, so what is the advantage in using the dielectrics? Okay, how to explain the concept. Right, so you need to know this now. Alright, so let's start by the first question for the tutorial. Let's start by question of the objective one. And question number 1. 3 2 farad capacitors are connected in 3 different arrangements. Seems like in X, in Y, also in Z. So seems like these 3 capacitors just arranged in parallel. These 3 capacitors just arranged in series, also parallel. Also for this, okay, they are arranged in parallel and then in series. Okay, so the question is, the equivalent capacitance for arrangements are Cx, Cy, and Cz. So that one is the total capacitance. Alright, so which of following comparisons of Cx, Cy, and Cz is correct? So we need to know which net capacitance or total capacitance is greater. Okay, alright, so as we know, under parallel arrangement, to calculate the capacitance, we just total up the values directly, isn't it? Which is C1 plus C2 plus C3. For this, we need to settle up this part first, which is they are arranged in series. So 1 over C1 plus 1 over C2, giving you 1 over C12, isn't it? And then 1, 2, and 3, they are arranged in parallel, so that C total equals to C12 plus C3. Okay, and then for this, we need to settle up this one first. So C1 and C2 just arranged in parallel, so we need to calculate C12 first. C12 equals to C1 plus C2. So C12 now arranged in series with C3, isn't it? So that to calculate C total equals to 1 over, because they are arranged in series. So C12 1 over C12 plus 1 over C3 equals to 1 over C total. Alright, so based on that, we just calculate the equivalent capacitance. So remember, equivalent capacitance, total capacitance, or net capacitance, they are the same. Okay, for the first one, under parallel arrangement, so this is the way how do we calculate the total or equivalent capacitance. Okay, for the second part, we need to calculate 1, 2 first, and then 1, 2, and 3. So 1, 2 just arranged in parallel, in series. So that 1 over, you will get this. And then 1, 2, and 3 just arranged in parallel. So this is the way how we calculate the equivalent capacitance. And then for the third arrangement, we just settle up this one first. They are arranged in parallel. So 1, 2 just arranged in parallel. So this is the way how we calculate the equivalent capacitance for 1, 2. And then 1, 2, and 3, they are arranged in series. Okay, they are arranged in series here, 1, 2, and 3. So that you will get 1.33 farad. So which one is greater? The greatest one is Cx, isn't it? So Cx greater than Cy greater than Cz. So which answer is correct? Cx greater than Cy greater than Cz. Okay, so the answer is A. Okay. Okay, next question number 2. What is the question? An air-filled capacitor is connected to a battery as shown in figure 2.1. So this is the capacitor and this is the battery. They are arranged in series. Okay. So, okay, we have some correction here. And suppose after removing the battery, so by taking out the battery, seems like there is no more power supply in the circuit. Okay, a piece of insulator such as mica is inserted in between the plates of capacitor. Which statement is true? Alright, so the keyword now just here. So this is the keyword. Okay, what is the hidden info do we have? Okay, so by removing the battery, there is no more power supply. Means that there is no more charger supplier. So that the number of chargers just remain constant here. Okay. Alright, so according to this, they ask you to choose the statement, okay, for the correct one lah. Okay, so A, the capacitance decreases. B, the potential difference across the capacitor decreases. C, the energy of the capacitor does not change. And D, the electric field between the capacitor plates increases. Okay, which answer is correct? Okay, so remember, by inserting the insulator, we may increase the capacitance of capacitor. But in this case, there is no more power supply, means that the charges now still remain constant. There is no changes in charges. Alright? So, based on that, okay, the answer should be, okay, now we just refer to the equation. Epsilon equals to epsilon over epsilon naught. So what is epsilon? This is epsilon r actually. Epsilon r, relative permittivity, okay, equals to epsilon over epsilon naught equals to C over C naught equals to V naught over V equals to E naught over E. Alright, so according to the equation, seems like epsilon naught and C naught, they are directly proportional, but they are inversely proportional to V naught and E naught. Okay, so by inserting the insulator, we have increased the capacitance, isn't it? So the capacitance just increased. So by increasing the capacitance, seems like permittivity also increased, but V should be decreased, E also decreased. Okay, so which answer is the best one? Okay, so let's check the answer. So as I told you before, by inserting the insulator, we have increased the capacitance, so that permittivity also increased, yeah, and then V should be decreased and E also decreased because they are inversely proportional to C. So first, for the first one, the capacitance decreases. It's wrong lah, because C just increased. Oh, I need to use the red one. Okay, so that one is wrong. The potential difference across the capacitor decrease. So the potential difference decrease because they are inversely proportional to C, isn't it? Okay, correct. The energy of the capacitor does not change. Okay, we need to check the equation of energy. Energy equals to U equal to half QV. It increases. So by increasing C, E supposedly decrease because they are inversely proportional. Also wrong. So the best answer is, yeah, B. Okay. Next, number 3. A parallel plate capacitor has a capacitance C naught. A second parallel plate capacitor has plates with twice the area and twice the separation of the first capacitor. So the capacitance of the second capacitor is most nearly to. Alright, so for the first capacitor, the capacitance is C naught. So we just assume that the area is A, the separation between plates is D. But now for the second capacitor, we have increased the area to be double. Okay, the area is double, so area equals to 2A. And then the separation now also double, so D equals to 2D. So what is the capacitance of the new capacitor here? Alright, so how do we answer the question? Okay, initially we just have our standard capacitor, which is C naught equals to epsilon naught A over D. And then for the new capacitor, the equation is C equals to epsilon naught A over D, where A become double, D also become double. Alright, double and double here, so 2 and 2 cancelling each other. Okay, giving you epsilon naught A over D, where epsilon naught A over D still equals to C naught. So that the new capacitance still equal to the original capacitance before. So the answer should be C. Okay, okay, next, let's continue by the subjective question. Number 1, two capacitors of capacitance 2 microfarad and 4 microfarad initially uncharged are connected in series with a 12-volt battery. Calculate the equivalent capacitance, the charge on each capacitor, and the potential difference across each capacitor. Okay, normally without giving you any diagram, better we just sketch a simple diagram. And normally for the first values given, we take it as C1 lah. So this is C1 and this is C2. And remember, the unit just in micro, the prefix is micro. So micro equals to 10 to the power of negative 6. Don't forget that for the substitution later. Alright, so what do we have? C1, C2, and V0. V0 is our potential supply. Okay, so they ask you to calculate the equivalent capacitance, the charge on each capacitor, and the potential difference across each capacitor. Alright, so I just sketch a simple diagram to be like this. Okay, what do we have? This is C1, this is C2 connected to our power supply, which is 12 volt. Okay, first they ask you to calculate the equivalent capacitance. So remember, under series arrangement, to calculate the equivalent capacitance or total capacitance, it must be 1 over C, isn't it? So 1 over C total equals to 1 over C1 plus 1 over C2. As I told you before, don't forget for the prefix, for in the substitution, 1 over 2 micro or 2 times 10 to the power of negative 6. Okay, let's say by ignoring micro here, it's wrong for the substitution, so that the answer also wrong, as long as the answer getting is correct. So remember that for the substitution, it must be complete with the prefix. Alright, so for me, I like to use the symbol the symbol of prefix. So 2 micro for C1 and 4 micro for C2. So by using our calculator, don't forget this is 1 over C total. Reverse it, you will get C total, so that you will get 1.333 microfarad. Okay, that is okay. Next, for the second part. Okay, for the second part, they ask you to calculate the charge on each capacitor. So according to the arrangement just now, seems like they are arranged in series. So remember, under series arrangement, the number of charges on each capacitor should be the same. Because seems like the current flow through each capacitor also the same, isn't it? So now Q1 equals to Q2, which is equals to Q total. Okay, so this is the hidden info should know by student. So under series arrangement, Q1 equals to Q2, which is equals to Q total. So that we just calculate Q total using Q total equals to C total V total. C total calculated just now. This is our C total calculated before. Substitute here. And then V total is the potential supply. So the potential supply is 12 volt. So by substituting these two values, and then you will get Q total. So that Q total equals to 16 microfarad, where Q total still equals to Q1 also Q2. We need to state this because the question asks you to find Q1 and Q2. Without this statement, seems like we haven't answered the question yet. Alright, so we need to write down that Q total getting here equals to Q1, 1 mark for this, and 1 mark for Q2 here. Okay, alright, settle for the second part. And then for the third part, they ask you to find the potential difference across each capacitor. So remember, for any series arrangement, and the potential drop by C1 is V1. The potential drop by C2 is V2. So under series arrangement, V1 plus V2 equals to V total. Alright, so this is the hidden info. So how do you calculate V1? V1 equals to Q1 over C1 from the equation of Q equal to CV, isn't it? V1 equals to Q1 over C1. V2 equals to Q2 over C2. Q1 calculated just now, 16 microcoulomb. Okay, Q2 also 16 microcoulomb, substitute here. C1 and C2 given already, which is 2 microfarad and 4 microfarad. Substitute, then you will get the answer. So V1 getting is 8 volt and V2 getting is 4 volt. For V2, we may use other equation, which is V total equals to V1 plus V2. V1 getting now is 8 volt. V total supply is 12. So 12 equals to 8 plus V2. So that V2 equals to 12 minus 8, giving you 4 volt. Still the same as before, isn't it? So we have two different methods in calculating V2. Okay. Okay, so let's continue by the next question, number 2. Alright, for question number 2, for the system of capacitors shown in figure 2.2, determine the charge on each capacitors and potential across each capacitor. Okay, so how many capacitors do we have? 1, 2, 3, 4. Okay, for any question to be something like this, and I think to make it easy, we need to label each capacitor now using C1, C2, C3 and C4 labels. Easy for us to calculate the values later. Okay, so for me, I like to label to be like this lah. So this is my C1, C2, C3 and C4. So seems like C1 and C2 just arranged in series, C3 and C4 also arranged in series. Am I correct? Okay, because there is no junctions in it. The current through C1 and C2 still the same. Also the current through C3 and C4 still the same here, isn't it? So 1, 2 just arranged in series. Also 3 and 4 arranged in series. So for any series arrangement, we may total up the values to be like this. So this is C12 and this is C34. Okay, they are arranged in series. And at last here, we may conclude that C12 and C34 just arranged in parallel, isn't it? So remember, for any parallel arrangement, the potential should be the same, isn't it? Okay, so in this case, potential of 12 equals to the potential of 34 equals to the potential supply. So V here equals to 90 volt. Also here still equals to 90 volt. Why? Because they are arranged in parallel. So by knowing V here and here, by knowing C12 also C34, how do we know? We may calculate it, isn't it? 1, 2 just arrange in series, so 1 as over C12 equals to 1 over C1 plus 1 over C2, so that you will get C12. So by knowing C12 also V12, we may calculate Q12, isn't it? By getting Q12 here, we know that 1 and 2 arranged in series, so that Q1 and Q2 equal to each other, which is equals to Q12. So that by knowing V here, by calculating C12, we may calculate Q12, where Q12 equals to Q1 equals to Q2, because they are arranged in series. Still the same for C34. Okay, we just calculate C34, which is 1 over C34 equals to 1 over C3 plus 1 over C4. Then you will get C34. And then V34 still equals to 90 volt, isn't it? So by knowing V, by knowing C, we may calculate Q. So by getting Q34, we know that Q34 equals to Q3 equals to Q4. Why? Because they are arranged in parallel. So this is the way how do we calculate and the values needed here, which is the charge on each capacitor. Alright, so let's calculate the answer. Alright, so this is the hidden info shown by student lah. And C1 and C2 just arranged in series, so that Q through each Q on each capacitor still the same. Q1 equals to Q2, which is equals to Q1 2. And then for the potential should be V1 plus V2 equals to V12 lah, which is equals to V total, because they are arranged in parallel. So V12 equals to V total here. But remember, V12 equals to V1 plus V2. V1 is V drop by C1 and V2 is V drop by C2, or V across C1 and V across C2. So total up the values giving you V12, which is equal to V supply. They are arranged in parallel, isn't it? Okay, so still the same for 3 and 4, which is arranged in series. Again, Q are the same. Q3, Q4 equal to each other, which is equal to Q34, and V across 3 plus V across 4 giving you V34, which is equal to V total or V supply. Okay, so V12 and V34 equals to V total, which is V supply lah. Alright, so let's calculate the answer. Okay, we just start by 1, 2. So first we just calculate C12. So 1 over C12 equals to 1 over C1 plus 1 over C2. Why do we need to use this equation? Because 1 and 2 just arranged in series. So by substituting the value of C1 and C2 into this equation, so that you will get C12, which is equal to 2 microfarad. Again, for the substitution, remember we need to put the prefix here, or still the same to 3 times 10 to the power negative 6. Okay, so remember that for the substitution it must be correct. Without any mu here or any exponent numbers, seems like the substitution is wrong, so that the answer getting also wrong lah, as long as the answer is correct. Okay, so remember that. So by getting C12, and then we just calculate Q12. So Q12 equals to C12 multiplied by V12. C12 getting out is 2 microfarad. V12 equals to V supply, which is 90 volt. They are arranged in parallel, isn't it? So that you will get Q12. Q12 getting out is 180 microcoulomb. So remember, the question asks you to calculate the charge on each capacitor, so that Q12 equals to Q1 equals to Q2. So this is the answer. We need to put this statement, okay? Because Q1 equals to 180 microcoulomb. Q2 also equal to 180 microcoulomb. Without writing, okay, without written this thing, what happened? We haven't answered the question yet. So 2 mark lost already, which is for Q1, also for Q2. So remember that. And then by doing the same thing for 3 and 4, so we just calculate 1 over C34 equals to 1 over C3 plus 1 over C4. Substitute the value of C3 and C4 into this equation, so that you will get C34. By knowing C34, and then we just calculate Q34 equal to C34 multiplied by V34, substitute all the values, and then you will get Q34 again, which is Q34 equals to Q3 plus Q4. Don't forget to state this, the answer for Q3 and Q4. Okay, next they ask you to calculate the potential across each capacitor, which is V1 V2, V3, and V4. That is a potential across each capacitor lah. Alright, so how to calculate V? Okay, by using the equation of V equals to Q over C again, from the equation of Q equal to CV, isn't it? So that V equal to Q over C, so that V1 equals to Q1 over C1. Q1 getting before, C1 given already, then you will get V1. So that from for any series arrangement, V total equals to V1 plus V2. So that V2 equals to V total minus V1. V total given is 90. V1 getting now is 60, giving you V2 equals to 30 volt. And then by doing the same thing for V3, V3 equals to Q3 over C3 from the equation of Q equal to CV, isn't it? Alright, so Q3 getting is 120 micro and C3 given is 2 micro. So that you will get V3 equals to 60 volt. Again, V total equals to V3 plus V4 because they are arranged in series. Alright, so that V4 equals to V total minus V3. V total given now is 90 volt. V3 getting now is 60 volt, so that you will get V4 equals to 30 volt. Alright, so this is the way how to answer question number 2. Okay, let's turn to question number 3. What is the question? Alright, seems like quite interesting here. This is little bit, we are talking about a conceptual question. We need to understand very, very well chapter 2 for this question. Okay, so what do we have? In figure 2.3, this is the figure. We charge a capacitor of capacitance C1, which is 8 microfarad, by connecting it to a source of potential difference of 120 volt. The switch S is initially open. The switch S still open means that the switch still off. Alright. Once C1 is charged, the source of potential difference is disconnected. Okay, first what do we have? We just charge this capacitor to our power supply. Okay, we just connect this capacitor to the power supply. So we are talking about the charging process of C1 and using 120 volt. And then by completing the charging process, then we just take out the power supplies. No more V here. And then we just connect C1 and C2 by turning on the switch or by closing the switch lah. By turning on the switch, we have connect C1 and C2. On that time, C1 react as our power supply lah. So some of the charges transfer to C2. Okay, so we are talking about the charging of C2 by C1 actually. Something like that lah. Okay, so what happen? The charging process still occurs there until the potential of C1 and C2 become equal to each other. When the potential become equal, then there is no more Q transfer from C1 to C2. So this thing happen, okay, for this situation. Alright, so for this question, first they ask you to calculate what is the charge Q0 of C1 if switch S still left open. So by left this switch open means that still off, there is no connection between C1 and C2, so C2 is not function. Okay, alright, so what do we have now? Just C1 and V only. So what is the value of Q? Okay, using Q equal to CV, isn't it? So that one is the Q stored by C1. Alright, but remember the keyword is once C1 is charged, the source of potential difference is disconnected. So when C1 is completely charged, then we just take out the power supply. No more 120 volt here. Okay, means that Q not getting before still remain constant because there is no power supply, then there is no supplier for the charge lah. So the number of charges should be remain constant, which is equal to Q not before lah. Okay, and then we just turn on the switch as before that. What is the energy stored in C1 if switch S is left open? Okay, so we may calculate the energy stored by C1 using U equal to half QV. Okay, this is the way how to answer this question. Okay, and then for the second one, the capacitor of C2 is initially uncharged. So C2 is really empty. After we close switch S, by closing switch S means that we have connect C1 and C2. C2 is really empty, but C1 is really full, fully charged, isn't it? So on that time, C1 reacts as a battery or power supply, and the C2 is really empty, so that some of the charge and some of the charges now in C1 will be transferred to C2. Okay, we are talking about the charging of C2 lah actually, and this thing happen again and again until the potential of C1 and C2 become equal to each other. So when V become equal to each other, no more charging process, then the charging process stop already, then no more charge supplied from C1 towards C2 here. Alright, okay, so from this, what is the potential difference across each capacitor and what is the charge on each capacitor? So remember, the potential become equal at last, so we need to know the concept or principle, how to calculate it. Alright, and what is the total energy of the system after we close switch S? So by closing switch S, we have connect C1 and C2 so that these two capacitor functioning already, so that we need to calculate U1 also U2, and then we calculate U total, which is equal to U1 plus U2. So this is the way basically how do we answer the question. Okay, alright, so let's answer the question step by step. Okay, initially only C1 connected to the source, so that the number of charges stored by C1 is Q0 equal to C1 V0. V0 is the potential supply, which is 120 volt. C1 is the capacitance of capacitor, which is 8 micro, so that you will get Q0 stored by the capacitor C1 now is 9.6 exponent negative 4 coulomb. Okay, so remember, and then when C1 is fully charged, then we just take out the power supply, isn't it? So no more supplier for the charge, so that Q0 still remain constant. Okay, because there is no supplier for the charge. Alright, for the second question, they ask you to calculate the energy stored by the capacitor. So on this time, seems like on the C1 functioning, so that the energy will label it as U1. U1 means that U stored by C1 equals to half Q0 V0. So this is Q0, Q the charge stored by C1, and V0 is the potential supply before, so that you will get 0.058 joule. Alright, and then for the second part B, we have disconnected the power supply, isn't it? Okay, so remember, no power supply, so that Q still remain constant. So Q initial equals to Q final. Q initial is Q0 calculated before. This is Q initial, okay, which is stored by C1 only. After that, by taking out the power supply, and then we have connect C1 and C2 by closing the switch, isn't it? Switch S. So that Q final equals to Q stored by C1, also Q stored by C2. So that Q final is Q1 plus Q2, where Q1 is C1 V1, Q stored by C1, and Q2 is Q the charge stored by C2, which is C2 V2. Alright, so remember, for the charging process, it will stop until the potential become equal at last, isn't it? So that V1 equals to V2, so that the charging process stop already. So on that time, V1 equals to V2, we take it as V only. Okay, so we may simplify the equation to be like this: C1V plus C2V to be C1 plus C2 multiplied by V, so that V equals to, this is Q0, sorry, Q0 over C1 plus C2. Q0 calculated before, so remember Q0 still the same because there is no supplier. Okay, alright, so Q0 equals to Q0 before, C1 and C2 given already, substitute into the equation, so that you will get V. So V getting out is 80 volt. So at last, V across C1 and C2 equals to 80 volt. When the potential equals, there is no more charging process. Okay, so the charges is not transferred anymore from C1 to C2. Alright, and then we just calculate Q1. Q1 equals to C1V. Okay, V getting out is 80 volt, C1 given already, so that you will get Q1. So this is Q stored in C1, and then Q stored in C2 equals to C2V. V is 80, C2 given already, so that you will get Q2. So this is Q1 and this is Q2. So remember, Q1 plus Q2 still equals to Q total. Okay, because the charge is remain constant according to the principle of conservation of charges. Alright. Okay, at last they ask you to calculate U total. So U total equals to U stored by C1 plus U stored by C2. So U by C1 is half Q1V, and U by C2 is half Q2V. V still the same, which is 80 volt, isn't it? So this is Q1 and this is Q2. Substitute into the equation, and then you will get the answer. So U total now is equal to 0.038 joules. Okay, I think enough for today. So this is part 1 for tutorial 2. Later we just continue by the second part. Okay, so I think that's all. Thank you. Assalamualaikum.